So we're going to move into chapter 7, and I don't want to oversell this, but I probably will. It's inevitable. But this is kind of the big concept that we've been building towards for most of the semester, and especially the last two chapters. When we looked at stuff like the normal distribution and the t-distribution, I mentioned a few times how we don't get quite all the details with the computation, and it is a little bit weird to me in a math class to have stuff like that where we're not seeing every single thing. That's certainly not the way that I would like to, and not the way that a lot of you would like to. Admittedly, a lot of stuff is pretty complicated to do by hand. I'm sure all of you could learn that, but it would take a lot more background and a lot more work when, truth is, most people would ask the calculator to do it anyway. But even then, a lot of that stuff is a bit floating and unmotivated stuff about finding percentiles and z-scores. It's good. It's worthwhile. Some of that stuff hopefully was actually interesting, but I think that this stuff here with hypothesis testing, conducting hypothesis tests, which is what we're going to be spending a lot of the next few chapters on, not just 7, but 8 and also parts of 9, that really provides the motivation for why we care enough to include things that we can't actually see in proper detail. Now, does that mean that you need to have chapters 5 and 6 mastered in order to get onto chapter 7? No, but you're probably better off having a good backing with it. And conversely, this also doesn't mean that once you get chapter 7, chapters 5 and 6 will thereby become much easier. Now, you're probably still going to have to stumble through the same sort of processes, the same sort of button presses on the calculator, as it were, regardless of how well you get chapter 7, but I do think that getting good at this in particular will help a lot in terms of building that sort of fundamental understanding of why we care about these things, because this is a very broad and useful topic, and I think is, as I said, our big motivator for why we do essentially all that we do for the second half of this class. And to start us along the process of learning what hypothesis testing is, how we conduct a hypothesis test, why we might want to conduct a hypothesis test, I'm going to start with a couple of brief anecdotal examples where we're not going to get a whole lot of detail in terms of how the test itself would run, but we are going to see why we might want to run one. Now, for the first example, let's say that you're going to a car lot because you want to buy yourself a car, and when you get up there, the dealer comes up to you and says something like this. Listen, let me level with you for a minute. I know you came in here with a really fixed budget, you gotta work with that. I understand, you're a college student, you gotta make what you can work. But we just got something that rolled in the other day. I'm not even supposed to tell you about it yet because it's not quite in the system. But I think you'd be really missing out if you didn't give this a try. At the very least, look at it. It gets about 50 miles to the gallon, man. You're not going to want to miss it. Just trust me. If you don't like it, you don't like it, but I really think you will. Let's just go over there and check it out. Now, in terms of statistics, there's obviously some things that dealer said that we would want to pay close attention to if you're actually buying a car, but for our purposes here in this class, the main thing we want to get caught up on is that idea that the car gets about 50 miles to the gallon. Now, about's a bit of a weasel word in itself, and it's not quite the sort of thing that we love using in this class to begin with, but for our purposes, we're going to assume that that is a fixed value, and that it's something like a population value, that if they were going to take every single car like that hypothetical that was going to be sold to you, you would expect the population mean gas mileage to be 50 miles per gallon. So, in our notation, we'll say that we expect, based on what the dealer said, that mu is equal to 50 mpg. Now, 50, that's pretty good. It's not the very best on the market anymore. It's certainly a lot better than what we were thinking of in those old days where a lot of people were driving Hummers and we were hoping that you could get above 10, but even still, it's a bit of a stretch, I would say, A lot of people drive cars that get in the 30s now, some even get in the 40s. A few do get 50s and above, but it's still not quite that common yet. So you might think to yourself, well, that car dealer, do you really trust him? Do you really trust any car dealer for that matter? You know what their job is. Their job is to, well, sell you cars.
Belly, this doesn't cost money, it makes money. You make the payments by plowing driveways on the side.
They want you to give them as much of your money, as you possibly can.
Well, I really should discuss this with my wife.
Your wife?
What, do you think I'm going to buy a $20,000 truck just because you make that noise?
Well, you walk out with the
I'll take it!
worst car possible for that deal. Maybe. Just depends on how ethical they are.
I can't believe you bought that plow. We can't afford it.
If you're going to get mad at me every time I do something stupid, then I guess I'll just have to stop doing stupid things.
Good.
Fine. I'll never ever do another stupid thing. Good night.
Didn't that hurt?
No.
But the point is, they are trying to sell you something, and up to a certain point, they can't outright lie about what the car is and what the car can do. They'll exaggerate as much as they can, because, again, they like money. And specifically in that context, they like your money. They want your money. But even if the car dealer's not really lying, even if there's some manufacturer decree that says that model should get 50 miles to the gallon, well, the manufacturer is basically a car dealer with more money and more options. They're still trying to sell you the car. In a sense, everyone's trying to sell you something if you want to think about the world in that lens. But anyway, that manufacturer, just like the car dealer, they can't quite go to the level of lying, at least not so much, but they are going to push the boundaries as much as possible, and they've been caught pushing the boundaries as much as possible in some cases to make sure that what they're trying to sell looks as good as they can possibly make it. Just like the dealer, because they're just a bigger dealer. So you might see that 50 miles per gallon, and unless that car is a Prius or a Tesla or something, you'd probably look at it and say, well, is the value actually smaller? So 50 miles per gallon is probably not realistic. Maybe you're hoping it's bigger, but more likely you think it's going to be smaller. For another example, another anecdotal example, we can think about, say, looking up an old broadcast or some old news headline and a video auto plays, and it says something like this. A recent study conducted by the CDC shows that 51% of adults believe that antibiotics can help deal with viruses. Okay, hearing that, well, we're going to put it in our statistical notation, thinking back like we did in Chapter 6 in terms of proportions. We might say that the population proportion as represented by that study is 0.51. Now, things like antibacterials, antivirals, antibiotics, it's all a little bit complicated. It's easy to get those names backwards at the very least. And more than that, even if you do get the name right, well, it's still complicated to really understand what's going on with an antibiotic versus a virus. And you may not know that they actually don't really interact in any direct way at all, that an antibiotic's not going to help with the virus, and if anything, it might hurt because taking too many antibiotics can affect the way that your immune system responds to certain stimuli. So it could actually make things worse. So that 51% is 51% of people who would be wrong. But maybe it's a reasonable 50%. That doesn't seem like the worst number in the world. However, something else that we might want to think about there is that maybe this information was compiled in 2018. And in 2018, people, I won't say they didn't have a reason to think about viruses and antibiotics, at least not very deeply, but I will say that more people had more reason to do so since then.
So we immediately threw the kitchen sink at it. All kinds of meds, monoclonal antibodies, ivermectin, Z-Pak, prednisone, everything.
And more people had some pretty strong opinions about it that they developed
You're coming close to me. You're coming close to me.
over the last few years, or however many years it's been since you watched this video, because I'm obviously dating myself a little bit, but that 51% may have been good once, but in the time since, people have developed, maybe, different perspectives.
Maybe the reason why we have people in the hospitals all this mask wearing. Did we ever think of that?
And as a result of those different perspectives, it might no longer be accurate. So, depending on timing, we may wonder, has that proportion, the proportion of people who erroneously believe that antibiotics help with viruses, changed? And these two types of questions here are the fundamental questions that come to mind when we're dealing with hypothesis testing. We're going to get some more detailed notation later, but for now, what we should understand is that when we're taking a hypothesis test, what we're doing is we're looking at some information like this, some believed parametric value, and saying, does it still hold up to scrutiny? Was it initially a false authority that was presenting the information? Or, for that matter, was it something that had been very good, had been perfectly reasonable, but due to circumstances, isn't anymore? Because even if we have all good, perfect things once, well, no matter what we do, no matter what we want, things do change. Change is one of those laws of life that it does just happen. Even if you want it, even if you don't, things don't stay the same forever. Otherwise, we would be stuck as we were thousands of years ago, still held accountable by the whims of inane and further remote wealthy families. Oh no.
And you profusely sweating.
Maybe some things don't change quite as much as we want. But in this case, we're looking at one situation where they do, or at least where they may have. And to try and figure out how they may have changed, well, this class being statistics, what we can do is we can go out and we can find people. We can find ourselves some samples, whatever we're looking at here, it would be people, and find those who drive that car and see if they know what their gas mileage is and see if that gas mileage average lines up with what the population average is supposed to be. And we can get two birds stoned at once, as it were, and then ask them what they feel about antibiotics and viruses and see if this value is also reasonable by taking an X bar here and a P hat there. But, okay, great. We've got a whole bunch of numbers. And maybe we've got a couple of statistics to compare to some parameters. Maybe when we do that, we get that P hat is also 0.51. Or maybe it's like 0.52. And we get the X bar to compare to mu is like 45. And looking at those two things, you can say to yourself, okay, cool. They changed. Or maybe they didn't. But what's the use of it? It could have been a really good sample, it could have been a really fair sample, or maybe it wasn't. We've seen a whole lot of ways that sampling can and does go wrong, even with good intentions. And even with good intentions and a good sample, okay, that's not the whole picture. Why do we assume it's good enough? Well, that is where we actually get into the detail, the meat, as it were, of hypothesis testing, and that's where we bring in the stuff from chapters 5 and 6 with those distributions, where we can actually describe how meaningful those changes we might see are in the context of our sample as compared to our supposedly true parameter. But those are things we're going to see further on in this chapter and later in 8 and 9. For now, the next thing we're going to look at is a quick bit more in developing that notation so we can better understand what we're looking at in a symbolic way. This is a math class. We like our symbols. We're going to see more of those next.